it kind of went unremarked recently, but anyway, so nanotech, like briefly, is like, sorry, turn that off, is like essentially being able to manufacture things at a molecular level. So there's been tons of it in sci-fi and things like that, but it is just like any crazy powerful technology like nuclear was, or genetic engineering, or any of those type of things. It's incredibly, like, its potential is huge, but one of the things is, I forget who came up with it, but they were talking about kind of the existence of humans in our research as like reaching into a jar and there's a predetermined number of balls. Some of them are white, so you pull out stuff and it's like pretty much all to the good or neutral. Then there are gray balls like nuclear or genetic engineering, where if used inappropriately, obviously can be super destructive. But, you know, like nuclear isotopes used in radiation therapy, there's so many, you know, or power or whatever, there's gray balls. Then there's, and we don't know how many and we don't know which ones they are, there's a potential for humans to reach in and come out with what is a black ball, which is essentially an existential threat that'll fucking kill us. Nanotech, a lot of people, and intelligent people have signed on, like Nobel laureates have said that we should discontinue all research into the field, period.
Whoa.
Yeah, and these are no joke people. Like, there's a great article called Why the Future Doesn't Need Us by a guy named Bill Joy, who's like or used to be the CEO of Sun Microsystems, and he came up with like Java and C++ language. Really smart guy. And because you know, like Kurt Vonnegut Jr. had one of his books where there was the gray goo scenario, which is essentially they let nanotech kind of out of the box, and it, because of the way it replicated, so one of the ways that people picture it is that you essentially make little robots that can make other little robots out of the molecules around them, any molecules. So things like the replicator technology on Star Trek, that would most likely be like could be initially a nanotechnology, right? You dump all your household waste into a thing, it disassembles it and reassembles it into food or products or fuel, water, whatever you need, because it can take the building blocks, like the carbon, the hydrogen, it can assemble them into whatever you want.
This is real, or this is a fantasy world?
This is the theoretical element that they're starting to look at, right? So, but essentially, the geometric progression, if you have one robot that makes 2 robots, that make 4 robots, that make 8 robots, you know that progression, right? 8, 16, 32, 64, 128, 256, and next thing you know, you're at billions, and essentially they turn the entire ocean into gray, like a gray jelly. They just kill everything in the ocean, and that's just the way that the world is because they let this thing out of the box. So it's a fascinating thing, because this is something, again, actually that same night I think, that I was talking about quantum entanglement and, you know, iterations of the universe, is that, you know, at first we didn't know about, say, disease, right? And then we thought it was like smells that made disease, and we had all these silly ideas, and then slowly we got to the germ theory of disease. So we started to use things like antibiotics, and that's like fighting disease on a chemical level. So we're still kind of doing that, chemical/molecular. But I said to my friend, I was like, at some point, if nanotechnology emerges and we can do it properly, we can just have, and this is what a lot of people envision, is either permanent or temporary or some mix between the two, where you inject yourself with nanorobots and say, people know you have cancer, you inject the anti-cancer ones, they go and they physically, you know, like a person and another person would fight, the robots go and kill the cancer on a physical level, molecule to molecule, right? Like, so it's really fascinating. And then there's also the element of, if you can build anything starting from molecules, you eliminate the need for transportation, because you can recycle all your basic stuff back into brand new products, you know, no byproducts, no such thing as food waste. So once again, being able to probably deconstruct and reconstruct things from molecules, from the building blocks of everything around us. The thing with it, why it's been essentially stalled out, is what they call the build problem, which is that, they oftentimes use like a small thing. The number of molecules in like this lighter is like trillions, right? So even if you had a machine that could do like thousands per second, it would take like hundreds of years to build this lighter. So they're like, well, it's one of those things off in the future. But I believe some scientist recently, researcher at the University of Alberta, claims to have solved the build problem through he used machine learning to figure it out. So if that's true, and you can start assembling things at the rates of like millions or billions of molecules per minute or second, then you start to be able to build anything out of anything. So obviously, one of the things that is great about that is you could engineer things like graphene or things that are ludicrously strong and very, very light, super, super durable, or super compostable, right? Like you could make things that work like silverware, but you put them into a solution and they completely dissolve and are, or forget about pesticides, but you have just nanobots go out and kill all the fungus, the molds, the pests, right? So, or climate change, just have a whole bunch of nanobots that eat carbon and spit out whatever you want, gasoline, right? Like, and this is the kind of things that people are actually doing, like somewhat. They're able to start doing some interesting stuff with it. So it's hard to talk about it briefly, but essentially if you think about the simple fact that you could control matter at the molecular level, and you could have robots that are completely invisible, maybe work in a swarm fashion, things like that, and you have the capacity to deconstruct things, reconstruct things, and if you started to be able to understand interactions between like body proteins and DNA, which are molecules, who knows what you could do. Now, the scary parts, the black ball part of it is, what if, because once the knowledge is established and the build processes become normal, like just like anything, once you're able to manufacture whatever at a high scale, if you can imagine, like I said, imagine if you're like a fucking white supremacist and you get a nanotech lab and you're able to identify a particular protein that only exists in colored people. And you release your nanobots into the world in several cities, and all they are programmed to do is disassemble anything it finds with these particular molecular markers, right? Or anything. You start to be able to do some pretty scary stuff, or just accidentally. And this is the same thing with AI. So what's great is, of course, they're galloping along at the same pace, so you'll probably have AI helping nanotech to get faster as it goes. But if you imagine self-replicating robots that are the size of molecules and are able to alter matter at the molecular level, you can get some pretty scary scenarios if things just go wrong.
So does this already exist?
So all the theory is there. Now it's mainly just the engineering to get it where it's cost effective and reliable. And an interesting book like by Michael Crichton called Swarm, one of the problems with the build problem a lot of people are looking at, and instead of trying to build little machines, what they're doing is using parts from life. So they'll, like the little spinning tail on a bacteria. Well, what if you just get that part spit out by a bacteria or by a genetically engineered something to spit it out, and then you assemble your robots out of like biological molecular components. So there's all kinds of crazy shit that's happening.
Can you tell me some nanotechnologies that are already fully in play right now?
That I have to look at, because again, there are things that people say it depends on what level, because they already have like electron tunneling microscopes that can move like single atoms. So they are able to start manipulating things at that level. I haven't kept up on it a lot recently, but from a clean perspective, nanotechnology is probably only kind of acknowledged as such if you want to be totally purist about it, is if we are from molecules up building things, and I don't think we're quite at that level yet. So if you could directly, and this is something that people are starting to be able to do, if you could just print out, which some people have done, which is still technically genetic engineering, but if you're able to like control specifically all the molecules all the way up from the base, right? Whereas what even people like this Craig Ventnor, who was one of the guys who did the Human Genome Project, he printed artificial life. So he took a cellular membrane from something, sucked out what was in it, and he put in one that was printed out. But essentially they were using, you know, the 4 amino acids that are necessary to make DNA and RNA and just printing it out chemically. But so they were using the molecules as they were already assembled and existing. But so to keep it like smaller, I would say it doesn't exist in its pure state yet, but trust me, there's a huge amount of money in it, because if people can be the first individuals to control like a manufacturing sector that requires no access to any kind of fucking earth resources that aren't already just everywhere, recycling becomes a whole different thing when you can take something that's made out of paper, use the carbon to make it into something else that has carbon. So you use the cellulose and make it into something completely different. He said, like, because it's really fascinating when you think, you know, a human and that metal cup are made from a lot of similar molecules, right? You know, carbon, iron, all those kind of things. So if people can nail this, and then all of the applications of it are absolutely ludicrous, from manufacturing to recycling, like I said, battling climate change, medical technology. If you can physically go in, especially in the case of like invasive organisms, if you can go in and program little robots to go in and kill cancer cells, kill all of these infectious diseases, you literally could just have your smartphone hooked up to a bunch of sensors that they're coming out with that say, oh, take this little pill, and those things could have, this is where people get scared, of course. They say, you could take it and it only has one individual robot, and it goes in your body, or maybe it has the components in the pill, and once you take it in, it makes 1,000 of itself, or 1 billion of itself, goes through and rids you of all of those various things, that the problems that you have, and then they're disassemble themselves, or they just die, and your cells just clean them out, and you pee them out like 2 days later, and you're totally fine. But of course, what what if they go wrong? What if, because essentially they're a build process, what if there's a build error? What if they decide instead of this protein, they attack the proteins that make up your brain, or all of the cells in your body, you just melt into the ground? Or people are like, oh, we'll have nanotech, because you know what people will do. They'll use it in infinite idiotic applications, and it'll just, that's why, as I said, there was that actual, I think 120 different scientists who are saying that genetic engineering, artificial intelligence, and nanotechnology, those 3 things, which are probably some of the biggest investments right now, should never be touched, because of the fact it's incredibly unlikely we'll be able to control them once. And of course, as I said, AI, machine learning, is currently helping genetic engineering, right? It's currently assisting and bootstrapping us thousands of times faster than we could ever do it. Like, and it's good in some senses. Like, there's a solar cell company that used machine learning to test thousands of materials virtually to try to make a more environmentally friendly solar cell. And they said it would have taken like 150, 200 years for them to test all these materials for their usefulness. But the AI did it in like 2 weeks. Now that's great with medical technology too. Test all these possible complications with medicines before they hit a person, right? You know, virtualize a person's, system, and all of these great things. But at some point, the rubber's going to hit the road, and they're going to put something out there. And what people worry about, just like with AI, is it the genie? Like, how do you put the fucking genie back in the bottle? And that's the gray goose scenario. That's because of geometric replication. If you do have self-replication, and there's even an article released that these people, scientists, made this new, and I forget, it was out of like frog components or something, and they were just testing them as like building blocks for a different kind of cellular engineering, and they ended up just replicating themselves. You think, okay, that was in a lab, blah, 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 blah. Imagine if it's a molecular sized robot that can self-replicate at a geometric rate. It could dump the Earth in minutes. And it's no joke. Like, that's like serious math behind it. Let's say one day, if it decided to just like unzip all the complex carbon shit, all life on Earth could just be a pile of fucking goo in like a couple of days, because it's finding the means by which to replicate itself everywhere. Anyway, so yeah, like, it's a really, really amazing potential, because you start to get down to the level where you're in control or have mastery over the building blocks of physical reality. And there's a AI scientist who I like who says, oh, nanotechnology is boring. And I think I talked about it with you. He was talking about creating dense computers, but he said femtotechnology is what's really cool, which is where you take the subatomic particles and you create new forms of matter entirely. So new atomic structures. And that's what he was saying, where, and we'll just finish on this, where he's saying, like, so if you're building computers, what you want, because of the restrictions of the speed of light, is you all want the components as closely, densely packed as possible. The only problem with that is the generation of heat. So he said, inevitably, and size and mass. So if you want gigantic computing structures, you'd probably start building them in space. And then if you have things like nano and femtotechnology, then you're not restricted by physical components. You build things out of the subatomic molecules. And let's just stick with nanotech that's actually feasible. You're building things at the molecular level, so you don't have to worry about etching things or using acid to etch things or lasers. Fuck that. You're making it exactly how you want from each carbon molecule up. So he said you would build a denser and denser and more closely packed massive computer that eventually would be on the verge of collapsing into a black hole. And if you could control that process and still maintain the computing power and coherency of the network as it moves into a black hole, he said that, and if this always happens about 200 years after, let's say, radio technology, transistors are discovered, it might explain the lack of alien life in the world, because instead of actually traveling the stars, we just live in a virtuality based in this supercomputer that can outstrip any possible physical reality and simulate anything you want and be ultra powerful. But you're essentially, because of black holes, information doesn't leave them. You're cut off from the rest of the universe. But because of your high level of technology, you'd be able to communicate through quantum tunneling to other civilizations that exist in black holes, and thus you would have no evidence of any advanced life, because everyone hits that standard. Or maybe they're even guided, a la Star Trek, where the black hole sends someone, is like, hey dude, you're just about to do this, here's this trick, and welcome to the club, and then poof, you're gone. So anyway, yeah, watch a couple YouTube videos on it, and maybe I'll look up where it's at, because I'm curious about that build problem guy. But yeah, it's an ultra fascinating field, and I get excited about it because of its potential. But it might be one of those black balls. It might be the last ball we pull out of the jar before we're all dead.